Now we're going to look at a couple of examples for computing factorials where we want to simplify 7 factorial over 4 factorial and 59 factorial over 58 factorial. Where to work with these, what we should understand is that if we really want to, we can multiply these whole things out in terms of every single term, see what simplifies, or maybe just plug the whole thing into a calculator, because the calculator can do this stuff pretty well, but point is it's a little bit clunky, not really the best way to go about it. So instead what we're going to do here is look at some techniques we can use for simplifying these to make our life a little bit easier and actually be able to approach them without needing any external help. So for our first case, we're given the terms 7 factorial over 4 factorial. And first thing we can do is just think about what that value 7 factorial looks like. Well, it's 7 times 6 times 5 times 4 times 3 times 2 times 1. But what we can really see that is as 7 times 6 factorial still divided by 4 factorial. Well, it's a half step, but it doesn't really help us. Well, let's try doing that again. Because 7 is still 7, and 6 can be thought of as, or 6 factorial, can be thought of as 6 times 5 factorial, and we're still over 4 factorial. Okay, we're getting closer, maybe. Maybe you can see where this is going, maybe you can't, depending on how much experience you have with this, or how comfortable you are with multiplication algebra. But the real magic occurs in our next step, where what we can do is note that we still have 7, 6, and now we have 5 times 4 factorial, because 5 factorial is 5 times 4 times 3 times 2 times 1, or 5 times 4 factorial. And the nice thing here is that once we get to this point, 5 factorial, the 4 factorial on the top cancels with the 4 factorial on the bottom. We don't actually need to write out all of these steps here to get to that. We could really just go from this down to there if we want to, but it's good to see where it comes from in a little bit more detail first. But long and short of it is, all we'd be left with is just 7 times 6 times 5, which is 210. Now there is one very important thing I should mention with this type of algebra in particular. That is 5 times 4 factorial is most definitely not equal to 5 times 4 quantity factorial. When it comes to factorials, these terms grow incredibly quickly, and multiplying things and then taking the factorial throws off the order of operations and gets you with a much, much larger number. And this relationship only holds in some very, very special cases. The vast majority of the time, the left side is not equal to the right side, and in fact, this is much smaller than that. Anyway, for our second case, looking at that 59 factorial over 58 factorial, you might say, oh wow, that looks terrible, because you got to multiply 59 things and then multiply 58 of them and do a whole lot of algebra, but that pattern up there actually makes it really nice, because 59 factorial is just 59 times 58 factorial. And since we're dividing by 58 factorial anyway, the vast majority of what would be a problem here gets killed off by a little bit of algebraic convenience, and all we're left with is just the value 59. And these types of computations are something you're going to want to get very comfortable with, as we'll be seeing them a lot more now that we're getting into the meat of what we're going to see in this couple of sections, talking about permutations and then in 11.3 combinations.